Yellowstone National Park is home to one of the largest supervolcanoes on Earth, and it's earned its reputation as a ticking time bomb. Because with an area the size of Rhode Island that could be wiped out in an instant by another eruption like the one that gave the park its name 640,000 years ago, we can't help but wonder how many other doomsday devices are hiding beneath our feet. Yellowstone's magma chamber extends nearly 90 kilometers below the surface. And if it erupted tomorrow, it would send a plume of ash more than 30 kilometers into the atmosphere. But what about the areas surrounding this magma chamber? What happens to them when the big one finally blows? To answer that question, we need to look beyond Yellowstone because although no one is currently monitoring these regions closely enough to predict their risk of eruption, scientists have good reason to believe that they might pose just as much of a threat. So join us as we take you on a tour of 5 places that will disappear if Yellowstone erupts, and find out why experts are working overtime to identify more hidden supervolcanoes around the globe. When Yellowstone blows, don't expect Wyoming to come out of it unscathed. In fact, the entire state will likely suffer catastrophic damage. That's because, unlike most volcanoes which build up from the ocean floor, Yellowstone lies completely within the North American continent. And because it's part of the so-called Ring of Fire, it's formed as the result of a hotspot, or a plume of hot magma that extends deep into the Earth's mantle from a stationary point far below the moving tectonic plates. This means that instead of sitting atop a weak point where the plates meet, Yellowstone sits right in the middle of a much stronger region called the lithosphere. And that makes it especially dangerous because there's nothing to stop the magma from traveling sideways once it starts rising. Yellowstone's most powerful eruption occurred 2.1 million years ago and created the Yellowstone caldera, an enormous crater that stretches 43 by 56 kilometers. Most of Yellowstone's subsequent eruptions since then have been confined within the caldera itself, but that doesn't mean that the surrounding states should let their guard down. One study published in June 2022 in the Bulletin of Volcanology found that during its most recent eruption, Yellowstone sent ash and debris not only over much of the western United States, but also as far east as the Appalachian Mountains. Even small eruptions at Yellowstone can throw ash over large parts of Wyoming, Idaho, and Montana. And the researchers concluded that the eastern fallout could reach the Mississippi River Valley and the Great Lakes region. In 2021, some of the world's leading experts on supervolcanoes met at the Yellowstone Supervolcanoes Eruption and Risk Workshop held at the Idaho National Laboratory to discuss the risks posed by the megavolcano. According to geologist Michael Poland from the U.S. Geological Survey, their worst-case scenario estimate suggests that an eruption would generate pyroclastic flows that travel hundreds of kilometers down river valleys and deposit beds of hot volcanic debris over an area roughly the size of Florida. All told, 90,000 square kilometers or 35,000 square miles of land across 4 states could be buried under several meters of ash. But Wyoming residents might take some small comfort in knowing that they wouldn't be alone. The same holds true for the residents of New Zealand's North Island who live near Lake Taupo, home to the country's largest volcano. New Zealand is known for its geothermal activity. Hot springs, geysers, and mud pools bubble across the North Island. And it's all thanks to the 2 tectonic plates that meet off its coast. The Australian and Pacific plates are slowly converging, meaning one is sliding underneath the other. And where they meet, the rock is hotter than anywhere else. As a result, New Zealand sits along the so-called Ring of Fire, home to 75% of all volcanoes and 90% of earthquakes worldwide. The North Island is home to 10% of New Zealand's population. So it's important that people understand the risks associated with living in such a volatile place. Like Yellowstone, Taupo formed over a stationary hotspot, except Taupo's hotspot is thought to be a little more active. Its most recent eruption was 26 times more powerful than the one that destroyed Pompeii and Herculaneum in 79 AD. The eruption generated a Plinian eruption column that reached 28 kilometers into the atmosphere and unleashed 27 cubic kilometers of material. Ash fell over an area of 7,500 square kilometers, and pumice landed as far away as Australia. Scientists estimate that the eruption would have been visible from every corner of the globe. If it erupted again today, the blast radius would be about the same. The dense ash cloud would block out the sun, casting New Zealand into darkness, and global temperatures would plummet by several degrees for years. The entire North Island would be buried under 10 centimeters of ash, destroying everything in sight. But even though New Zealand has a comprehensive emergency management system in place, much of the country hasn't prepared for a super eruption. So while officials try to raise public awareness about the danger, some experts are looking to the skies. In 2012, researchers developed a new tool for monitoring volcanic eruptions using satellites. It's now used to keep tabs on Mount Vesuvius and other volcanoes in Italy. And it could one day be used to monitor Taupo. The technology detects changes in gas emissions, which precede eruptions by days or even hours. If it were in place over Taupo, authorities would have more time to evacuate residents and lower the death toll. But New Zealand is hardly alone. In fact, scientists are discovering that supervolcanoes lurk on every continent. Of the 5 known supervolcanoes on Earth, 3 lie beneath the Atlantic Ocean. And while it might seem reassuring to know that these giant ticking time bombs are out of sight and out of mind, it's really not that simple. That's because the seafloor hides a lot of geological activity that can't be studied up close. And without a good understanding of the processes occurring beneath the surface, scientists can't effectively monitor these volcanoes. Take the Central America volcanic arc, for instance. It's a chain of volcanoes running along the Middle America Trench between Mexico and Panama. These volcanoes form as a result of 2 tectonic plates colliding. The smaller Caribbean plate is sliding underneath the larger Cocos plate, and wherever the 2 meet, whether it's above or below the ocean, the result is explosive. The region is home to at least 10 major active volcanoes and dozens of minor ones. There are significant threats to the 10 million people who live nearby. Between 1912 and 1913, the region saw the deadliest volcanic eruption of the 20th century, which includes both world wars. It was the eruption of the Santa Maria volcano in Guatemala. More than 6,000 people lost their lives after pyroclastic flows engulfed nearby villages. And in 1980, the nearby Volcán de Fuego erupted almost daily for several months, claiming hundreds of lives. But these events pale in comparison to what would happen if a super eruption were to occur in the region. Ash would cover parts of Central America and the Caribbean. Pyroclastic flows would race through the valleys, and people within 100 kilometers of the volcanoes would likely die. So it's crucial that scientists monitor this area more closely. And one way they're doing so is by building new seafloor observatories that can transmit data back to shore via underwater cables. They may also rely on something as simple as paper to keep tabs on the world's most dangerous volcanoes. In 2017, a group of researchers from Oregon State University set sail on a research vessel equipped with a towed array of seafloor sensors. Their goal was to map the seafloor near the Mariana Islands and Japan's Ogasawara Islands, both of which are located along the Ring of Fire. They used a type of equipment called a land-sea electromagnetic system, or LODES, which uses a magnetic field to measure subtle changes in the sea floor caused by earthquakes. By measuring the waves generated by earthquakes, the team was able to construct detailed maps of the underground structures and identify potential weak points that could erupt. And they did all this by dropping small pieces of paper at sea. The papers were coated with iron oxide, which served as tiny magnetic compasses. When the paper strips moved, they left behind tracks that revealed the strength and direction of the magnetic field. Thanks to the success of this mission, scientists are now working on a larger project called the Integrated Ocean Drilling Program, or IODP. Using advanced seafloor drilling technology, they'll collect samples from various depths to learn more about the makeup of the Earth's crust and improve our understanding of how volcanoes form. Because there's so much we don't know about the inner workings of volcanoes, it's incredibly hard to say whether or not they might erupt. But thanks to projects like IODP, we may one day be able to identify the early warning signs of a super eruption and get everyone out of harm's way before it's too late.